Hello. In today's video we'll discuss about some more concepts related to signals. The first point, signal mask. As we know that masking is nothing but hiding something here. So in the Unix environment system, so we are blocking the sum of the signals which are generated to a process. That means whenever a particular signal is generated to a process B, assume that, so we can block that particular signal. That means that signal will not be delivered to the corresponding process. This mechanism, what I can call as a signal mask. Just we can find it there as the one point I have given there. Each process in a Unix or POSIX system has a signal that defines which signals are to be blocked when generated to a process. A blocked signal depends on the recipient process to unblock it and handle it accordingly. That means the recipient process would be blocked until the certain information or kind of the message it should get it. Okay, so based on that the blocking has been removed. If the signal is specified to be ignored or blocked, it is implementation dependent on whether the signal will be discarded or left pending when it is sent to the process. If signal is specified ignored, that means it could not have any impact on that particular process. A process initially inherits the parent signal mask when it is created, but any pending signal for the parent process are not passed on. That means when we know that the fork API has been used for creating the child process, the parent process is created the child process. In that case, all the properties of the parent is inherited to the child process in maximum, but some of the properties are not inherited. In this case, masking value will be inherited, but pending signals will not be inherited here. The process may query or set its signal mask via Sigprocmask API. That means we can check it currently which are the signals has been added as part of the signal mask by using Sigprocmask API here. So for that concept, it is having the three arguments. One is command, one is sigset, one is new mask, one more is old mask. Here new mask defines the set of the set to be set or reset in calling process signal mask. Means either we can add the new signals or we can remove the existing signals here. New mask. Old mask is the previous mask with respect to that process. And CMD specifies how the CMask value will be used by the API here. There is some certain possible values are there, like sig set mask overrides the calling process signal mask with the value specified in the new signal mask argument. That means as we know that Control C and Control V, copy and paste. I wanted to copy and then later on I wanted to paste on a one page. Assume that a page contains certain contents. If I directly paste, then existing contents will be overwritten here. Yes. So this kind of the things what I can call as a sig set mask. Sig block is nothing but add the signal specified in the new mask argument to the calling process signal mask. That means the half of the page already contents are there. Just I wanted below of that, just I wanted to add the new contents. In that case, the existing information and the new information is there. Here we are not overriding here. Signal unblock removes the signal specified in the new mask argument to the calling process signal mask. That means if suppose if you are interested to remove the certain signals from the signal mask, just I wanted to use the sig unblock here. If the actual argument to a new signal mask argument is null pointer and the command argument will be ignored, that means the second argument value, if I taken 0 value, in that case the command argument will not have any impact. That means either set mask or block or unblock could not have any impact if I take the 0 value, and the current signal mask of the process will be remain same. The old mask argument is the address of the sigset variable, that is will be assigned calling process within the signal mask prior to the signal process call. Means usually what happens, before calling the signal process mask API by the process, the old mask value will be written here. If the actual argument to a old mask is null pointer, no previous signal mask will be returned. That means if suppose old mask value is 0, null pointer, in that case it could not have any values currently. The return value of the sig process mask call is 0 if it succeeds and -1 if it fails. I mean the API here. Sigset is a data type defined under the signal header file. It contains a collection of bit flags, with each bit flag representing one signal defined in the system. So that means what I am using the sigset, it is representing the some bit flag like either 0 or 1. So here are the some of the supporting APIs for signal mask. Sigempty set. Sigempty set API clears all signal flags in the signal mask argument here. I mean all the value will set it to 0 here. Signal add set sets the flag corresponding to signal number in the signal mask. That means, say for example, if suppose interrupt signal is there, for that it is the value is set it to 1, otherwise the value is remain 0 here. Sig delete set API clears the flag corresponding to signal number. So here with respect to second one, it is exactly opposite. Means we are clearing only one flag value with respect to a particular signal. Sig fill set API sets the all flag values in the signal. It is exactly opposite of the sig empty set. It will clears, then it will add it here, all the flag values. The return value of the sig empty set, sig add set or sig delete set and the sig fill set is 0 on successful condition and -1 on failure condition. Then one more API we are using, sig is member API. It returns 1 if the flag corresponding to signal number signal in the sig mask is set to 0. If not, then it is returning the -1. So this is member is nothing but just we wanted to check is a member of signal mask or not by calling the signal is member API here. So it is one of the program example with respect to signal process mask. The following example checks whether the signal interrupt signals present in a process signal mask and add it to a mask. If it is not there, then clear the segmentation fault signal. So the first part is the declaration what we are having. Then after that we are calling the sig empty set, means we are initializing all the flag values to 0. Next we are calling the signal process mask 0 and 0. So as I already told, currently we are not adding anything. If it is 0 means it will take the current signal mask value here. We are just retrieving the current signal mask value. If it is failure, then it will returning the -1. So -1 is equal to -1, then it is executing the statement P error statement. Otherwise it is returning the other than -1, then 0. In that case it is executing the else part here. Sig add set, just I discussed this one. We are adding the flag value with respect to the one signal that is named as interrupt signal. Similarly, we are deleting the flag value with respect to segmentation fault signal. Next, we are calling the signal process mask with sig set mask. So as I already told, sig set mask is nothing but it overrides the existing signal mask value with the new signal mask value. That is nothing but currently we are wanted to set the one signal that is interrupt signal, and 0 means we are not ready to retrieve any old signal mask value here. Otherwise it is a failure case. In that case it is executing the P error statement here. A process can query which signals are pending for it via sig pending. I mean a particular process, say for example, as we know that whenever the different processes are sending the signals to a recipient process, and the recipient process can easily check it, how many signals are pending on it by calling the one API that is named as Sigpending here. So here Sigmask, based on the Sigmask only it can decide how many signals are pending. So the return value of Sigpending is 0 if it is successful, -1 if it fails. The Sigpending API can be useful to find out whether one or more signals are pending for a process and to set up a special signal handling method for these signals. I mean, we are calling the different methods like default action, ignoring the signal, or calling the user-defined function before the process called the Sigprocmask API to unblock them. I mean, as we know that Sigprocmask API, we can check it how many signals are blocked, or we can unblock by using with respect to process mask here. Sorry, signal process mask. As there is a small program has been taken here. In the first line, just we are setting the flag value with respect to signal mask. Next, in that we wanted to check any signal mask is pending. If it is failure, then -1 is returning, then this statement is executed. Otherwise, it is successful, then this statement is executed. Sig terminal signal. We wanted to check that whether this particular signal is pending on that particular process or not. How we are checking? So we are checking by calling the sig is member here. So signal mask here, we are using the existing mask value with respect to the terminal signal. If it is already set, then this statement is executed. Otherwise, no set is executed here. Next, we are having the sigaction API. The sigaction API is a replacement for the signal API in the latest Unix systems. I mean, as we know that we are using already signal API for handling the signals. That means either we need to call the default action or ignoring the signal, or by calling the user-defined function. The same thing we are able to perform by using the sigaction API as well. This sigaction API returns the previous handling method for a given signal. So it contains the 3 arguments. One is the signal number, nothing but we need to specify name of the signal. Next, second argument is pointer to structure that is named as sigaction. The third one is also a pointer to structure that is named as sigaction. We will see that what the sigaction is containing here. This sigaction is containing SA handler, nothing but what is the method you wanted to use. Whether you wanted to use the default action, then the 0 value will be taken. If I wanted to take the ignoring the signal, then the value will be 1. If I wanted to call any user-defined function, its value is other than 0 and 1. Next, SA mask. What are the signals you wanted to mask for that particular signal? You wanted to add this any special flag values here. The flag is a different value. We'll discuss shortly. Here, the SA handler already I told. Just we wanted to ignore our default action, or it is might be a calling the user-defined function. And SA mask field specifies additional signal that process wishes to block when it is handling the signal means you wanted to add any signals as part of the signal mask, then I need to use the SA mask field here. The SA mask field of the struct signal used to specify the specific handling for certain signals. Here, SA flag values may be 0 or SA no child stop. Means SA no child can be used when signal number is child signal. I mean, the particular child signal is generated, then I need to use the SA flag with respect to the value is SA no child stop. The effect of no child stop flag is that the kernel will generate the child signal to a process when its child process has terminated, but not when the child process has been stopped. Means already child process is terminated, but it could not be stopped. So in that case, this flag value is executed. If the SA flag value is set to 0 in sigaction call for child signal, the kernel will send the child signal to the calling process whenever its child process is either terminated or stopped here. the signal num